Everyone at home can see my screen okay? Yeah, okay. Thank you. All right, we're awake? Yeah, kinda? Sort of? Have fun. Almost. Soon. Oh. I mean, you wouldn't have to be, you wouldn't have to leave. You don't need your computer right now. All right, so 4.2. If two triangles are congruent, then their corresponding parts, angles, and sides are congruent. That should sound familiar, yes? You dealt with that in 4.1. Now, think about a triangle. If you're trying to prove two triangles are congruent, isn't that 3 different sets of angles and 3 different sets of sides? Isn't that potentially 6 different things you would have to show are congruent to show the two triangles are congruent? Yeah. Do you want to have to do that? No, me neither, right? No way. What we're going to learn about today, or one of the things we're going to learn about today, is a few different shortcuts. You don't necessarily have to prove that all 3 sets of angles and all 3 sets of sides are congruent in order for two triangles to be congruent. There are like a few shortcuts that will allow us to assume that the rest is also congruent. And then we're going to actually take some of those and write a few proofs with them. So we have 3 different postulates that we're going to learn today. They are the side, side, side postulate, which we abbreviate as SSS, side angle side, which is SAS, and angle side angle, which is ASA. What's kind of nice about these is they are exactly what they sound like they would be. So there's not a whole lot of like memorizing that has to happen with these. What the side, side, side postulate says is if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if you have 2 triangles and you can show that all 3 sets of sides are congruent, then that is enough information to say that the 2 triangles would be congruent. You don't have to worry about anything with the angles at all. Now, something that I want to make sure we know how to do is write a statement of congruence. So, for example, if you take a look at this picture, this is a picture of side, side, side. We have our 2 triangles. They're sharing a side, side AC, right? That's where they are joined along. If I wanted to say triangle, if I wanted to like show that these are congruent, if I said triangle ABC is congruent to triangle, how would I have to name the other triangle? If I said ABC. Ashley, you said ADC? So for this one, if you take a look, AB, see how it goes A, B, C? So it starts at A, it goes along your short side to B, and then across the long side to C. So I know it's tempting to start with A again because that's like where they're connected, but AB wouldn't go with AD. So any ideas of how we should start that one instead, Matt? Yeah, CDA. You want to start along that short side, go to the long side. So that'd be triangle CDA. Remember, you want those corresponding parts to match up. So AB goes with CD. That's kind of a good way to help you get started with that. Side angle side postulate, or SAS. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So 2 sides and the included angle. If you take a look at this picture here, we have that side AC is congruent to side DC. That's one set of sides. We have that side BC is congruent to side EC. And then included angle. What do you think that means? Included angle. Where do you think that would be? Or what does, like, if you hear the word included angle, what do you maybe visualize, Logan? Like, you mean like for this picture, like where your lines intersect? Mm-hmm. Okay, well, yeah, they'll definitely be the congruent ones. So yes, they will be equal. Where do you think, like in your picture, where do you think an included angle is going to sit, Braden? So you're thinking included, like added. We don't have to worry about adding anything. Think position wise. Like think about which set of angles here would be congruent. Ashley? Right, ACB and DCE. These would be congruent. Though in this case, they're vertical specifically, right? But take a look at where they are. Here, I'll zoom in a little bit. Take a look at where they are in relation to the sides that we're talking about. What do you think included could mean in this situation? Matt? Yeah, that's actually a really good way to think about it. Do I know anything about AB or ED? No. And isn't that angle directly across from it? Another way to think about it, well, how I kind of like to phrase it, is it's the angle where your two sides that you do have information about are connected. Included, I kind of think like in the middle of. It's not like technically the middle, right? Because it's not a segment or anything. But AC and BC connect at that angle. So that would be your included angle, or the angle that's between the two sides that we have information about. Okay? If I talked about angle A and angle D, those two angles are not the included angles because they're not where those two sides intersect. Does that kind of make sense, guys? Okay. Because the position of that will matter when you're trying to say that things are congruent. All right, so if I wanted to write a congruency statement here, if I said triangle ABC, what would I say for the other one? Triangle ABC. What do you think I would say for the other half of my congruency statement? Logan? Very good. Triangle DEC. And absolutely make sure you include that triangle symbol. If you don't, what are you saying? A plane. It's not a plane, right? It's a triangle. I guess technically it's probably in a plane. But that's not what we're talking about in this chapter. So DEC. Okay, good. The next one and the last one for today is angle side angle postulate. Similar idea to side angle side, but kind of like reversed. If two angles and the included side of one triangle are congruent to two, oh, this should say two angles. Here, a little typo here. Two angles and the included side of another triangle, then the triangles are congruent. All right, so two angles and the included side. If you look at this diagram here, we have that angle A is congruent to angle D. That's one set of angles. You have that angle B is congruent to angle E. There's another set. And then if you take a look at your sides, side AB is congruent to side DE. Now in this picture, isn't that side between those two angles? It's like the side that connects the two angles that we have information about. So that's where an included side is going to be. Are you going to pay attention, or are you just going to like play with your pencils? Great. Picking up a pencil could help instead of piling them on top of each other. But, what do I know? Yeah. All right. So, really the big thing with this is going to be just identifying which postulate you think you might use. If you can figure out which postulate would use, you can write a proof for these. Like guaranteed, as long as you kind of know your vocab. But can you use your vocab sheets? Yeah. Should you get rid of them? No. We're going to use the same vocab pretty much all year. So this says decide whether you can deduce by side, side angle side, or the angle side angle postulate that the given triangles are congruent. If so, write the congruence and name the postulate used. So when it says write the congruence, it wants like the congruent statement, like triangle, whatever is congruent to the other triangle, okay? So I want to take a look at like at least one of these together, and then I'd like you to try these out on your own. There is one that does not work. There's one that, yeah, sure, you have some information labeled, but it's not necessarily helpful. If you look at A, what I like to do with these is, first of all, see if there's any additional information that can be labeled. Like, will a shared side be congruent to itself? Absolutely. Vertical angles, maybe if you have parallel lines, there could be some congruent angles, things like that. And then I like to go from there and kind of see, well, do I have information about sides, angles, how many of each? So if you take a look, we have a set of congruent sides here. So there's one set of congruent sides. And then I see a set of right angles here. So that would be a set of angles, right? So I have one set of sides, one set of angles. What else do I have? Matt? Yeah, we have a shared side right here. So we can say that our shared side is congruent to itself. Get rid of my other markings here. But we have a shared side. I always like to label that as congruent to itself. So if you take a look, now keep in mind, guys, aren't these two separate triangles? So when you're trying to figure out which theorem or which postulate you're going to use, maybe like visualize these almost like split apart. Because it's kind of easy to look at this and you might notice the right angle, the shared side, and the other right angle and go, oh, angle, side, angle. But is that what the situation is in this case? No, what should it be, Ashley? Side, angle, side. You got to make sure you look at one triangle by itself, not like both of them combined. You have a set of congruent sides here, a set of congruent right angles, and then another set of congruent sides. So we would say side, angle, side. And then we're going to write our congruency statement. Oh, I guess I lied. We don't have to write the congruency statement because I didn't include pictures that had like labels. So we won't worry about that part. But we did it up here. Are we feeling better about how to do that now? Okay. I want you guys to try out B, C, and D. You don't have to worry about writing the congruence because the pictures don't have the labels that you would need for them. So just try B, C, and D. Figure out which postulate would work. Okay, what extra information you might have to label. There's one that does not work though. Try it out.
This is a side angle. I want to see probably. Yeah, I actually.
I mean, usually one of them does not work.
It's mine, right? It's not.
This one is not, because you don't have two sets of congruent sides. Like you
Like. So.
Not necessarily. You can't just show, but there aren't there, no, but aren't there vertical angles here?
Because.
Vertical angles will be congruent.
Oh, so it's
This
angle, side angle.
Yeah.
But because of this one.
Okay.
What?
Laughing at this. All right. I wish I had a good projector that wasn't blurry. All right, part B. Any additional information that we have that needs to be marked, labeled, etc.? Matt? Yeah, we have another shared side. I always recommend labeling it. You do have a shared side there. So, somebody else, what theorem did you say this one was? Julia? It is side, side, side. You have one set of congruent sides here, here, and then here. This is side, side, side. What about for C? Does this one work? No. You want to know a trick? Label it. It's not going to spell the right thing, children. When you label this, you have a set of congruent sides here, right? The double with the double, the single with the single, and then your triple here. Here, you have a set of congruent angles here, right? Here and here. You ready for some, I don't know, freshmen always get worried when I write things down like this. But if you take a look, don't you have another congruent set of sides here and here? Okay, there's a side. Don't you have another set of congruent sides here and here? Do you think that's going to be a theorem? No, it is not going to be a theorem. I'm going to give you a hint. It will kind of eventually be a theorem, but only for a very specific kind of triangle. No, there is no ass theorem. It doesn't exist, doesn't work, don't put it, okay? Not a thing. So that one is a no. Okay, that one does not work. What about part D? Look, angle, side, angle, because we also have our vertical angles here in the middle, right? So we have an angle, a side, and an angle. That one does not spell anything offensive, so we are good to go. Okay. Not offensive, but I don't know. I'm sure someone's mother would be like, who knows? I don't know. I mean, it still isn't a theorem, so it wouldn't matter.
But it is for a very specific.
Only for right triangles, because you can only be an ass if you're right, Jonathan. I know. I'm so clever. How I keep my job. All right, so are we ready for some proofs? I think so. Good news is, really, we have 3 proofs and then we're done. I actually think you guys will find these proofs not quite as challenging as the last one. I say that based on 7 years of teaching geometry. So I think you'll be okay. So for number 2, we are given that E is the midpoint of segment MJ and that segment TE is perpendicular to segment MJ. We are going to prove that triangle MET is congruent to triangle JET. First thing I would do, guys, always label your pictures, right? If you're given additional information, please label your pictures. So E is the midpoint. Well, let's go through and like plan it too before we start writing things down, right? If E is the midpoint, what else are we gonna know then? Matt? Absolutely. ME is gonna be congruent to JE. Okay, so we're gonna know that if E is the midpoint. We're also given that segment TE is perpendicular to MJ, right? So these are gonna be what kind of angles? Right angles, right? So are those two angles gonna have to be congruent? Yeah, we have congruent adjacent angles. What else do we have? There is a shared side. Yeah, TE is a shared side. So will we be able to use the reflexive property and say that's congruent to itself? That's how that works with that. I know there weren't any proofs in 4.1, but if you want to do anything with a shared side, it's in both triangles. So you would just say it's congruent to itself by the reflexive property. And that happens a lot. So that's like a nice, easy thing to kind of look for. All right, so let's put in our given. So E is the midpoint of segment MJ, and segment TE is perpendicular to segment MJ. There is our given. Now, if you take a look at your picture, haven't we basically already proved it? By what theorem? Or what postulate, Logan? Side angle side. All we have to now do is just write these things down, right? So once you've labeled your picture, look at your vocab, see which theorem you think or postulate you need to use, and then it's really just writing it down. So let's use our vocab first. I like to use your vocab first. The other thing about these guys is your order isn't as important, right? Unless there's specific steps that are tying together. But like here, it wouldn't matter if you use the midpoint first or if you use the, let's say, reflexive property first, okay? It's not a big deal. I'm going to use my vocab. So I think it was Matt that told us that if E is the midpoint, then we want to say that segment ME is congruent to segment JE. And that is the definition of a midpoint. Okay. So there is one set of congruent sides. We then also had perpendicular lines. Now, anyone have any ideas of where I could go with my perpendicular lines? There's more than one good option. We're going to do it the shorter way, but what do you guys think we could do? Perpendicular lines are something that threw us a little bit on our chapter 2 test. Logan? Does anyone know what like theorem or corollary you could say though for a good reason? Any ideas? There's, again, more than one good way to do it. The one, yeah, Julia? Uh-huh. So that's technically, it's not the definition of perpendicular lines, but that is a corollary, and you can just use that corollary. So that's actually the way we're going to do it. So we're going to say that angle MET is congruent to angle JET because perpendicular lines, or yeah, and there's a few different ways you can say this. I'm just going to write it as a statement. It was a corollary, so it doesn't have like, or maybe it was the perpendicular angle, perpendicular line theorem. Okay, again, it's okay to write either a description, right, or the name. So whatever you feel more comfortable with. Because as I've said, the names are kind of like arbitrary, right? It more depends on what it means. So I'm going to say perpendicular lines form congruent adjacent angles. I believe that is also the perpendicular lines theorem. Now, that's not the only way you could do that. Because you could also, there's a little bit longer of a way, like if this doesn't pop into your head, perpendicular lines make what kind of angles? 90-degree angles. So could we also state that both angles were 90 degrees and then set them equal to each other using the transitive property? Absolutely. Either would be appropriate. Okay, so it just depends on what you think of. All right, and then we now are actually done with our vocab, and we're going to move on to our shared side. Anytime you have a shared side, you can just use the reflexive property. So I'm going to say that segment TE is congruent to segment TE by the reflexive property. And this is a time where the reflexive property is required. You do have to do this because it needs to be mentioned in your proof. And now we're actually done. We've shown our two sets of congruent sides. We showed our included angle. So we can say that triangle MET is congruent to triangle JET by side angle side. Any questions about that? How do we feel about that one? You kind of see how it all works. And that's very, honestly, with these, there's obviously going to be a variation depending on the picture, right? What kind of vocab you're given. But that's the general process for proving two triangles are congruent. All right. On the next side, we move on to 4.3. The only thing that's different about 4.3 is you're going to take your proofs one little step further. We're now going to deduce information about segments and angles once we have shown that corresponding parts, once you have corresponding parts of congruent triangles. So what that means is I'm going to be giving you two triangles, and you're going to have to show me maybe that like angle A is congruent to angle X or something like that. Or maybe you'll have to show me that two segments are parallel. Okay. How you're going to do that is by first showing the two triangles are congruent. Once you've shown the two triangles are congruent, won't we know that all their corresponding parts are congruent? So you'll be able to say that any set of corresponding parts that I ask for is congruent. Or maybe you'll need to show that you have some congruent alternate interior angles, and then show me some lines are parallel, something like that. Those are the two like main directions that it'll go. So I gave you a little step process here to kind of help you guys out. To prove two segments or two angles are congruent, you're first going to identify two triangles in which the segments or angles are corresponding parts. So first, figure out what your two triangles are. 2, prove that they're congruent by either SAS, SSS, or ASA. Then state the parts are congruent using corresponding parts of congruent triangles are congruent. That's technically our definition of congruent triangles that you learned in 4.1. But this is a phrase we're going to use very often in our proofs. Also, just a heads up, it is often abbreviated to CPCTC, which you are welcome to use as long as you know what it means. Okay, so it's corresponding parts of congruent triangles are congruent. It gets abbreviated sometimes because this is a bit of a long statement to have to fill in proof after proof. Okay. And then we just have one small definition here. It's the definition of a line perpendicular to a plane. If a line is perpendicular to a plane, then they intersect, and the line is perpendicular to all lines in that plane that pass through the point of intersection. So you'll have your plane, your line is perpendicular to it, any other line that passes through that intersection, it will also be perpendicular to, which is helpful sometimes for showing that you have maybe a right angle or congruent angles, things like that. Okay. And then we just have 2 more proofs. And then we're done, and hopefully we should have a good amount of time to start on our homework. All right, so we are given here that segment A, B, and segment CD bisect each other at point M. I want you to prove that segment AD is parallel to segment BC. So we're going to prove that those are parallel. Now, we dealt with parallel lines a lot last chapter, right? Parallel lines, when you're going in the other order, remember parallel lines, they do one thing, only one thing, and that's give you congruent or supplementary angle relationships. So remember, the converse of that is if you have congruent angle relationships or supplementary angle relationships, will you have parallel lines? Yeah. So let's kind of work backwards through this a bit before we actually start writing it down. If I want to prove that my lines here are parallel, I either need a congruent or supplementary angle relationship. Does anyone see one that might happen here? We've seen this kind of like bow tie shape a few times. Anyone remember what angle relationship we can end up having? Logan? We will. Okay, that's one thing. We will have vertical angles at point M. We'll go ahead and mark that. That is true. It won't give me my parallel lines, though. Think like alternate interior, alternate exterior, same side interior, and corresponding. Do you guys see one of those that might occur in this picture? Nick? Alternate interior. Which ones could maybe be alternate interior, Nick? D and C. Does it have to be D and C? No. Couldn't you also do A and B? Yeah. Do I care which one you choose? No, I don't. Okay. So if we can prove, we'll go with the one that Nick said. If we can prove that angle A is congruent to angle C, then you'll have your alternate interior angles. They'll be congruent, and then will your sides be parallel? Yes. So we're going to need to figure out how to prove those are congruent. Now, to prove those are congruent, what do you think we're going to have to show about the two triangles? Any ideas? What do we have to say about the two triangles first before I can say that their angles are congruent? Logan? The triangles themselves are congruent. Once the triangles themselves are congruent, will all their corresponding parts be congruent? You could say any set of corresponding angles or any set of corresponding sides is congruent. You'll be good to go. Okay, so then let's start figuring out how we can say they're congruent. We got to find either side, 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 side angle, side, or angle, side, angle. Logan already pointed out some vertical angles to us. We'll definitely use those. What else could maybe be helpful? Matt? Yeah. Now, bisectors are a bit of a tricky vocab word. Bisectors will not, an angle bisector will automatically give you congruent angles. Segment bisector is a little trickier. Does anyone remember what a segment bisector gives you exactly? We will eventually have congruent angles, but there's kind of like an in-between step first. Ashley? Not yet. There's going to be something that then gives us the congruent segments. Julia? They make a midpoint. Yeah. Segment bisecting is a little bit tricky because what ends up happening is your definition for segment bisectors is that if two segments bisect each other, then they bisect at the midpoint. So what's going to happen here is we're going to be able to say that M is the midpoint. Then once we have the midpoint, will we be able to say we have a bunch of congruent segments? Yeah, we'll be able to say that segment AM is congruent to BM and that segment DM is congruent to CM. And then once we mention our vertical angles, are we pretty golden with saying these two triangles are congruent? Yeah, which theorem should we use? Ben? Yeah, side angle side. And then, can we then say that angle D is congruent to angle C? Yep. Then will we have parallel lines? Yep. Is it a little long? Yes, but That same general process is going to follow for ones like this, okay? So let's go ahead and put in our given. So segment A, B, and segment CD bisect each other at M. Now there's a little wording here I want to point out. Notice how it says they bisect each other. That's how you know you'll be able to show both parts there are congruent. If it just said that segment AB bisects segment CD, then only one of them is getting cut in half, okay? So just be careful with that wording there. All right, so now let's use our vocab. We have a bisector. So let's make sure we were listening. If we have a bisector, what are we going to be able to say next? Think about our vocab. What'd you say? Yeah, exactly. We're going to be able to say that M is the midpoint of segment AB and segment CD. And that would be the definition of a segment bisector. Good. Now that we have our midpoint, somebody else, let me know we're awake out there. What do you think we could say now? Now that we know M is the midpoint. And we could do this in 1 or 2 steps. It's up to you. If M is the midpoint, what else are we going to know? Ashley? Yep, absolutely. Segment AM is going to be congruent to segment BM. And then I'm going to do it in the same step. You could do it in 2 if you wanted. You just might need an extra line. And then we're going to say that segment DM is congruent to segment CM. And that is the definition of a midpoint. Do I have you guys so far? Okay. All right, so now I have my congruent segments. I'm kind of done with vocab at this point, at least provided vocab, right? So once you run out of your provided vocab, go to your picture. What was important in our picture? What additional information does our picture give us? Logan? Yep, there are 2 vertical angles. And by the way, especially in ones like this, if you have to like go through and like talk about a lot of different angles and things like that, you're always welcome to relabel your angles if you want with numbers. Like I know when I pre-give you guys a picture, right, sometimes they're labeled with numbers. You're welcome to do that. You just have to make sure you draw it in the picture so I can see what's what. But just since we already have a lot going on here, I'm just going to say that angle AMD is congruent to angle BMC. What reason would that be? Julia? Yes, very good. Vertical angle theorem. Good. All right. Now I have my 2 sets of congruent sides. I have my set of congruent angles. Are we good to say the 2 triangles are congruent? No? Do we have enough information? Yeah, for the triangles, we do have enough information. We're not quite done with the proof, but we can now say that triangle AMD is congruent to triangle BMC, and I don't care what order you say those in as long as your corresponding parts match up. What postulate allowed me to do that? This is one of the reasons why labeling your picture is so helpful here, is because if you have it labeled, it's so much easier to see. Julia? Very good. Side angle side. You had your set of congruent sides here, your vertical angles in the middle, and then another set of congruent sides here. Okay, so now I know my 2 triangles are congruent, which is great, but that's not my final objective, right? I need parallel lines. Parallel lines mean I need a congruent or supplementary angle relationship. So Nick, remind us, what angle relationship can we find in this picture? Yeah, alternate interior angles. Remember the little trick to look for your zigzag shape? So now that we know our triangles are congruent, am I allowed to say angle D and angle C are congruent? Yeah, because they're corresponding parts. So we can do that. So I'm going to say that angle D is congruent to angle C, and that is CPCTC. Corresponding parts of congruent triangles are congruent. If you don't think you're going to remember CPCTC, then just write the phrase, corresponding parts of congruent triangles are congruent. Okay, now, do I have congruent alternate interior angles? So do I have parallel lines? I do. All right, segment AD is parallel to segment BC. Now here's the tricky part. Do you guys remember what theorem that is? It was, I think, on a test we took not too long ago. Ben? Yep, good. Alternate interior angle converse or converse of the alternate interior angle theorem, whichever way you want to say that, okay? Or are you allowed to say the phrase if you can't remember? Congruent alternate interior angles, or if alternate interior angles are congruent, then lines are parallel, whichever you prefer. Good. Pardon the absolutely terrible handwriting. I don't know why, but some reason then like when I get to this class, my handwriting's worse than it is in the morning. I don't know why. I think it's just all the extra writing with the proofs. Questions? How do we feel about that one? I know it's long, but is the logic tying together for you at least? Say the two triangles, or figure out how to prove the two triangles are congruent, right? Corresponding parts are congruent, your lines are parallel. Okay, we got one more and then you guys will be able to get started on your homework. I wanted to make sure you guys had some time since there's proof. Are you shocked? Surprised that there's proofs? No, just sighing. They weren't on Wednesday. That was nice, right? All right. So for number 4, we are given that segment PO is perpendicular to plane X, and that segment AO is congruent to segment BO. We are going to prove that segment PA is congruent to segment PB. Now, if you are trying to prove that parts are congruent, what are you going to have to do first? Ella. Say the triangles are congruent. So let's first figure out how we're going to do that, right? So let me zoom in on my diagram real quick. And by the way, this proof is on page 128 in your textbook, just a heads up. So segment PO is perpendicular to plane X. Now, we have a line perpendicular to a plane. Did we just write a definition for that? Yeah, right above, right? If a line is perpendicular to a plane, then the line is going to be perpendicular to all the segments that go through that point of intersection. What's my point of intersection for segment PO and the plane? Logan? Point O. So if it's perpendicular to the plane, what else would it have to be perpendicular to? Which other segments here go through point O? Ella? Yeah. Segment AO and segment BO. So will those have to be right angles? Will they be congruent? Absolutely. Okay, we're also given that segment segment AO is congruent to BO. So there's a set of congruent sides. What else? Ella? Yeah, which side do they share? Yeah, they share segment PO. So will I have enough information to show those two triangles are congruent? Absolutely. By what postulate? Side, 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 side angle, side, or angle, side, angle. Logan? Side angle, side. Yeah, we have our shared side. We'll have our right angles here, and then our side that was given to us. Once we've shown that the two triangles are congruent, will we be able to show that segment PA? Well, that doesn't like show up at all because of the green. I picked a bad color. But will we be able to show that segment PA is congruent to PB? Yeah, because they're corresponding parts, right? So that's what we need to do. It looks like this picture makes it look a lot like weirder than it is. All right. So let's start with our given. So we are given that segment PO is perpendicular to plane X, and segment OA, or I'm sorry, AO is congruent to segment BO. That is given. Let's go through, let's use our vocab. If we have a line perpendicular to a plane, what did we decide we'd be able to say? This part we got to do like a little in between first. We can't go right to the congruent angles. We have a line perpendicular to a plane. Someone refresh our memory. What's that definition going to give us, Luke? No, changed your mind? Okay, that's okay. Matt? Exactly. So if we have that, that's a situation we have, right? If we have that situation, what do you think that allows us to say in our proof? Because the theorem or the definition Matt just read us doesn't say anything about congruent angles, right? What does it talk about, though? This is where understanding your vocab is important. Doesn't give us congruent angles, so we can't do that yet. Nick? Not quite yet. It will. What does it do first, Luke? Yeah, it first gives us perpendicular lines. That theorem allows us to say that these extra lines are also perpendicular. Does that make sense? Okay, so if we have this perpendicular plane, then we can say that segment PO is perpendicular to segment AO, and segment PO is perpendicular to segment BO. And that is what we just defined. That is the definition of a line perpendicular to a plane. Okay. Now we have perpendicular lines, right? So now what do we have? Logan? 90-degree angles. Now, this was a very common mistake on the Chapter 2 test. You guys were given perpendicular lines, and then you went right to saying that two angles were congruent. But have I even stated the two angles yet? No, I need to like show that they exist first and that they equal 90 degrees, and then we can say they equal each other. So we are going to say that angle POA equals 90 degrees and angle POB equals 90 degrees. What definition lets me do that? Julia? Yeah, perpendicular lines, but yes. Definition of perpendicular lines. We had perpendicular lines make right angles. Now what? I think we might need one extra line here, but that's okay, because I forgot about a little thing. Ella? The measurements are equal. Yep. So we can now, so how do you want to say that though, Ella? Yeah. Oh, and I forgot my little m, didn't I? Okay, so we're going to say the measure of angle POA equals the measure of angle POB. What property could we use here? Logan? Sure, substitution works for me. You can also use transitive if you prefer. Now, I've shown the measures are equal, but are we showing triangles are equal? No, Matt, what do I need to change it to? Change it to congruent. Yeah, that's why I forgot about this little step. We'll need a little extra line, but that's okay. Angle POA is congruent to angle POB. What definition lets us do that? Julia? Yep. At least I think we'll need an extra line. Don't quote me on that yet. Definition of congruent angles. Good. All right. So we now have, I know there's a lot going on here, so let's take stock of what we have so far. We now have a set of congruent angles, right? We were provided with a set of congruent sides. What else were we able to say based on our picture now? We mentioned at the beginning, but let's make sure we still remember. Julia? Yeah. Exactly. Segment PO is congruent to itself. We had a shared side. So we are going to say that segment PO is congruent to segment PO. What property lets you do that? Come on, guys. I've heard from the same 5 people all day today. I hope that more than just us know that. Matt. Reflexive. Good. Reflexive property. And yeah, I was right. We do need one more line. Sorry. Because what can I say now? I had my given set of sides. I found my angles. I now have my other set of sides. Ella? Yep. We can now say that triangle, and again, how you name these is completely up to you, but make sure you do them in corresponding order. Okay, so if you want to say POA, then you got to see POB and vice versa. So I'm going to say triangle POA is congruent to triangle POB by what postulate? Side, 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 side angle side, or angle side angle? Ben. Side angle side. Good. Oh, okay, side angle side. And now we're almost done. This is our last step, guys. Because if the triangles are congruent, then can I say that these corresponding measurements are congruent? Is that good? Can I do that? Yes? No? Okay, I'm not convinced, but fine. Segment PA is congruent to segment PB. Why? What's an appropriate reason? Julia? Yep, corresponding parts of congruent triangles are congruent, or if you'd like to abbreviate it. Oh, wait, what happened to that? Why did you guys even see that just happened? Did you notice how it went all weird? All right, so that would be C, P, C, T, C. Good. Hey, we're done. We very rarely get done early. So, I mean, that's something, right?